Alright, in the first video, we were looking at quadratic functions in vertex form, and we figured out what k and h do. K shifts the graph up and down. H shifts the graph left and right. Now we need to look at a. And again, I think the easiest way to figure out what a does is to use our calculator. So I'm going to draw the graph of x squared, and I'm going to draw the graph of 3x squared. There's x squared, and there's what 3x squared does. So what did that do? Well, most students will tell me what it did is it made the graph skinnier. And that's not really true. It looks skinnier, I agree. What it really did, though, is it really grabbed the ends and stretched them upward. It really does a vertical stretch. And I think the best way to see that is to look at the table. Oh, let me change my table setting here. So you can see what's happening is when x is 0, y is 0 for both of them. But when x is 1, y is 1 here, y is 3 there. The y value just gets tripled. When x is 2, the y value is 4, the y value is 12. So the graph isn't really being made skinnier. Technically, it's really being made taller. It's being stretched up by a factor of 3. Similarly, if I had a fraction here like 1/2, students in general would tell me that the graph is getting fatter. Well, it's really not getting fatter. It's really being cut in half vertically. All the y values are half as small. Now, the other interesting thing that happens is when this a value is negative. When the a value is negative, notice what happens. The negative flips the parabola. It makes the parabola go downward, and the 2 made it skinnier. Alright, so here's what a does. A does two things. If a is positive, the parabola goes that way. If a is negative, the parabola goes that way. So the first thing a does a flip. And then if a is bigger than 1, it could be positive or negative, so I put absolute values around it. If a is bigger than 1, the parabola is taller. And if the absolute value of a is less than 1, if it's a little fraction, the parabola gets skinnier. Or I'm sorry, it gets shorter. Alright, so how is this going to change what you do for homework? Not a whole lot. You're going to have y equals -2 times x plus 1 squared plus 4. The directions are going to be the same. The directions are going to be find the vertex and then draw me a graph. And again, within your graph, you're going to build me a little table. Well, once again, the vertex is controlled by this number and that number. This number is inside the parentheses. Inside the parentheses goes left and right. Left and right works backward. That's a +1. So our vertex is going to shift left 1. This number controls the up and down. Up and down goes the way you think it should. A positive goes up. So we have -1, 4. Beyond that, I'm going to build a little table. And again, I'm going to use my symmetry properties of my parabola to make building the table a little bit easier. I've got -1, 4. And something I notice about this parabola, this value is negative, which tells me this parabola is going to go down in this direction. So make sure when you plug in numbers, it goes down in that direction. Alright, so I'm going to go 1 unit to the right of the vertex. That'll be 0. And I know I'll get the same y number if I go 1 unit to the left. When I plug in 0, I have 0 plus 1, that's 1. 1 squared is 1. 1 times -2 is -2. -2 plus 4 is 2. So that gives me 2 points. 0, 2. And -2, 2. And I'll figure out one more value. I will go one more step to the right. That means I'll plug in the number 1, which means when I go one more step to the left and plug in -3, I'll get the same answer. Alright, so I plug in 1. 1 plus 1 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 4 is 4. I'm sorry, -8 plus 4 is -4. And so when I plug in -3, I'm also going to get -4. So 1, -4, and -3, -4. Alright, there's my parabola. Oh boy, didn't draw that one very well. But you get the idea. It doesn't look very symmetric, but it should be. Didn't curve very well over there. Should have been more like that. Alright. Alright, so here's your next batch of homework assignments. Where did we leave off? I forgot which number I did last. I think I gave you 4 problems before. Yep. So, here are problems numbers 5, 6, and 7, and the directions are the same. Find the vertex, and then graph. Y equals 1/2 x plus 2 squared minus 3. Y equals -3 times x minus 1 squared minus 5, maybe. And finally, y equals just negative x plus 2 squared plus 4. Alright, so give those 3 a shot. Alright, the last thing we have in this section is applications. So do you remember back earlier in this course, we spent a lot of time looking at data, and we looked at our data and found the equation of a line. Well, here's some data, and this is on page 334, problem number 36. I look at this data, and the first thing I notice is this data is definitely not linear, because it's decreasing for a while, and then it's increasing. That tends to make me think that it's more properly going to fit a quadratic equation. So, page 344, number 36. So, part 1 says, find a quadratic equation of f in the vertex form. And where f is the percentage of people living in the United States who are immigrants, t years since 1970. Alright, so we're looking for an equation. F of t is a times t minus h squared plus k. Alright, well the first thing I notice is that my vertex is right here. Remember, the vertex is always the lowest point on the parabola or the highest point. This appears to be a parabola that's going down for a while and then coming back up. So our vertex is our minimum. So the vertex is 70 years since 1970, and then 5. Well, that tells me my h number is 70 and my k number is 5. So right away I know f of t is a times t minus 70 squared plus 5. Now, to find the a value, we're going to take any other data point on the data, on any other point on the curve, and we're going to plug it in. We'll plug in a number for t, we'll plug in a number for f of t. Remember, f of t is just p. That'll give us our point. Now, looking ahead, I see that I want the number of immigrants in 2014, so I want to pick a number close to 2014, so I'm actually going to use the 2007 number. So I'm going to plug in 13 for p, and 2007 would be 107 years past 1970. Alright, so I got to get the a value all by itself. I'm going to subtract 5, so 8 equals a times 37 squared. So a is, I grab my calculator, 8 divided by 37 squared, I get 0.0058. So it looks like my equation is f of t, which is the same as p, is 0.0058 times t minus 70 squared plus 5. Part B. What is the vertex? Well, we already had to find that. The vertex is 7050. What does it mean in this situation? In 1970, 5% were immigrants. But it means more than that. Because it's a vertex, it also means that was the lowest percent ever. So it's important to note that the vertex always gives the high point or the low point. In this case, it's the low point. And finally, part C, predict the percentage of people who were immigrants in 2014. 2014 is 114 years past 1900. So we're going to plug in 114. Our answer will be P equals F at 114, which is 0.0058 times 114 minus 70 squared plus 5. I grabbed my calculator. 0.0058 times 114 minus 70 squared plus 5. We get 16.2%. Now, just to show you that this came out pretty good, I went ahead and I plotted my data, and I plotted the equation that I ended up with, this f of t equals 0.0058 times t minus 70 squared plus 5. Now, notice that the parabola fits the data better on the right-hand side than it does the left-hand side. And that's not a surprise, and the reason that's not a surprise is because to find this a value, I picked a point on the right-hand side of the data. If I'd have picked a point on the left-hand side of the data, then the parabola would fit better on the left than it does on the right. So depending on which point you use to come up with your a value, that will affect how well the data fits either on the right-hand side or the left-hand side. Alright, so for homework, I want you to do problem 33. So again, this is page 344. There it is, you can see it now. Page 344, problem 3. That'll be your last homework question.